Okay, so in our last section we were looking at ways to solve problems involving position and acceleration. Now we're going to take a look at some of the graphical techniques that are involved. Okay. Here's the thing. There's really two key fundamental things that you have to know for this whole topic. Okay. Let's say I set up a position versus time graph like this. My velocity versus time graph right below it. And my acceleration versus time graph just below that. What you need to know, okay, is that if I'm going from position and I'm trying to find velocity and then acceleration, as I go down, okay, as I go down to try to solve for these things, okay, I'm looking at slopes. Okay, so the slope of my position versus time graph is velocity. The slope of my velocity versus time graph is acceleration. If I go in the other direction, okay, I'm looking at areas. Essentially, all calculus is taking slopes, this is called differential calculus, and finding areas, this is integral calculus. That's it. That's the fundamental basis of all of calculus. You're finding slopes, you're finding areas. Physics and calculus are intimately tied together. Okay? It's very hard to do one without the other. Now here's the thing. With just these two concepts, slopes and areas, hundreds of thousands of people right now across the globe make their livelihood off the applications of finding slopes and finding areas. That's how important calculus is. Okay? And these are not like low-paid jobs. These are the highest-paying jobs outside. These are the highest-paying jobs in the world, pretty much, outside of straight entrepreneurship. Okay? You're finding slopes. You're finding areas. Okay? All the finance guys, they all do slopes and areas. All of the engineers, slopes and areas. Mathematicians, physicists, slopes, areas. Okay? This is two basic concepts, okay, the applications of which are immense, okay, and it drives our economy today. So now, let's take a look at the graphical interpretations of this, all right? So now, I was taking a look at a very complicated example. Probably can't see this. Hopefully you can't because it's kind of ridiculous. But we're going to take a look at one situation where we have the velocity, and we're going to try to find what the position and the acceleration are. And then one case where I give you specific numbers for the acceleration, and you try to find the velocity and the position. Okay. So now, let's take a look. Okay. First case is just going to be a general case, and we just try to get the shapes. So now, my velocity versus time graph. Let's say that I start off here. And for a certain period of time, I go like this. And then for the rest of the time, I go off like that. Okay? So now I need to extend my position versus time graph a little bit. And acceleration versus time graph looks okay. Now, it's always easier going down. It's always easier to go down. So now, my velocity versus time graph. I look at the slope of this. Okay? I don't look at what the fact that this starts off positive and it ends negative. I just look at the slope. Is that slope positive or is it negative? Well, up to this point, and you want to find some key points along the way. Usually zeros, places where it crosses. and places where there's a change. You kind of want to mark those out. So I mark those out. Now, the fact that it crosses 0 here makes no difference for acceleration. Acceleration doesn't care about that. Okay? Acceleration just sees that it's negative. Okay? The slope of my velocity first time graph between here and here is negative. So if I have a general case here, where I'm not plugging in any numbers, the general shape looks something like this. I can guarantee you, you will see something in the multiple choice section that looks like that. Along with, okay, what's my, oh, I probably should mark off the endpoint here. And I'll do that, like that. Now, what's the slope when it's here? Okay, yes, it's the velocity itself is below 0 here. It doesn't matter. It's the slope. The slope is positive. It's positive here, it's positive here, it's constant all the way through. Just mark that in blue. Okay, so that is, okay, hopefully you can see the difference in colors here. This is my acceleration versus time. All right, now, let's say I'm trying to find my position. Okay, well, here's the thing. I don't know where to start. I don't have a place on there that tells me where I need to start. Okay, I know that I start off, my velocity here, yes, the slope is negative, but it starts off in this area, my velocity is positive. All I know is that my position increases. I don't know anything about where to start. I have to give you a starting point. Okay? For those of you who are calc savvy, that's where the plus C comes in. Okay, you need to know where to start. So now, I'm right here. All right, my velocity is positive. I'm going to start off, I'm going to say that that doesn't work very well. I'm going to say that my initial position is right there. Now, all I know, okay, is that from here to here, if I look at the area, and I don't have a specific number, but my area here is positive. Okay? If it's above 0, okay, it increases. If it's below 0, it decreases. Okay? So now my position is going to increase till it gets to here. Now, here's the thing. At this point, wherever it's 0, wherever it crosses 0, my slope has to be 0. So let's just say that it gets to this point. I can't say specifically where it would cross. Okay, I don't have any numbers. But I know, or if it even gets to back across 0 here, but I know that it has to be, at this point, it has to be 0. I didn't give you any numbers, so we're just looking at the general shapes. After this point, okay, after this point, all right, my velocity, my slope here has to go negative. Up to this point, this is the slope of position versus time is velocity. Right here, my slope is 0. Here, my position has to be increasing. My velocity is positive, so my slope here is positive. After this point, my velocity is negative, so my slope has to go negative. So until it gets to, say, this point right here, and I'm saying it's a little bit below, okay, it's negative. At this point, now, okay, it changes direction. So now it's really an inflection point, okay, until it gets to here. So now this is, my velocity here is 0, so my slope here has to be 0. After this point, my velocity is positive, so my slope here has to be positive, and it would look something like that. Again, without numbers, you can't come up with any specifics. So let's take a look at a case where we can look at specifics. All right, same ideas. Okay, I'm going to erase all this off. I'll just redraw the whole thing. Maybe make it a little bit bigger. So again, position, velocity, acceleration. So now, I'm going to start off, okay, my acceleration is going to start off here at -4. The units are going to be meters per second squared, but we're not really worried about units right now. After 20 seconds, it's going to get up to +6. So my graph of acceleration versus time looks something like this. Now, right now, I'm going to challenge you, listener. Always label your axes. Okay. I want you to pause. I want you to figure out at what time this crosses. Okay? At what time the acceleration is positive. So go ahead and pause. Okay. So now, after thinking about it for a little bit, all right, the slope here, okay, this increases by 10, it goes over by 20, my slope is 1/2. So now that means every second this increases by 1/2. Okay, so it's going to take 8 seconds for that to cross over. Now, I know that 8 seconds where it crosses over there is going to be important, so I'm going to mark that off. Now, again, when you go up, you have to have a starting point. So, I'm going to say that my velocity, I'm going to try to keep it relatively simple here. My velocity will start off I'll start off here at 24 meters per second. Okay. So now, what I want to do is figure out what my velocity versus time graph looks like. So now, move the velocity over here a little bit. Okay, now, let's keep it like that. So I start off at 24 meters per second. Now, I'm going to use the area here to figure out what my velocity will increase to. Now, a couple things here. First of all, I know at 8 seconds, I have to have a 0 slope. So I know my velocity is going to decrease, and it has to look something like this. I know my velocity has to decrease because the slope, the slope of my velocity versus time graph is acceleration. My acceleration starts off negative, so it starts off with a negative slope, and it's 0 here, so it has to be pointed down until it gets to here. So now, what is the area of this? This is a triangle. I've got 8 along here, 4 along here. The area of that triangle, 8 times 4, 32. Take 1/2, 16. So this has to drop off to 8 meters per second. Okay. If it's below 0, you take away. If it's above 0, you add. So now over here, I've got a triangle. And I know that this has to go off and increase. So it gets to my endpoint here. And it's going to be up higher, like that. Okay? I want to figure out what this gets to, what my final velocity is. So I look at this area, 8 seconds to 20 seconds. So this is 12, this is 6. So the area here is 12 times 6, okay? 12 times 6 is 72, take half, 36. So this has to increase by 36 from when it was here. So this will increase all the way up to 44. Okay? So this is my velocity versus time graph. Now my position versus time graph, let's make it simple. I'm going to start off my initial position at 0. Now, I'm going to ask you a question, and then I'm going to ask you to pause. Does my position ever go negative? Does position ever become negative? Taking a look at your velocity versus time and your acceleration versus time graph. Hit pause. Okay, so now, here's the thing. My velocity is decreasing, but it's still positive. My velocity is always positive. It decreases between 0 and 8 seconds. Okay, it's slowing down, but then it speeds back up again. Okay, it's always going forward. So my position versus time graph has to do something like this, where, yeah, it's, so I have to think about this for just a second. So the slope of position versus time is, so now, between here and here, it's increasing. Okay, the area will increase. Okay, it's not adding quite so fast as when it's here. So now, my slope looks something like this, and it's just going to go off and become much more positive as it goes along. It starts bending upwards. Okay, and it's going to become greater and greater and greater. Now, I want you guys, you can try to take the areas here. That's going to be pretty difficult. We're not there yet. Okay, trying to figure out what your position is going to be when you get to here and when you get out to here. If you're in Calc 2, go ahead and do it. If you're in Calc 1, Fun Calc, Problem Stat, as it's sometimes called around here, just take it easy from there. Don't worry about it. We'll get to it. I'll probably hold off on that for most of the first half of the year. We'll come back to it. Okay? All right. Thank you very much.